Hi everybody, I'm Tom from AWS, and today I'm joined by Chris from Socrata.
Hi, Tom.
Welcome, Chris. So tell us, what does Socrata do?
So we're a data organization focused entirely on the public sector, and our goal is to help governments use data to make better decisions.
Awesome. And so what types of data are we talking about?
So we're talking about all sorts of different kinds of data, from financial data to public safety to public health, that kind of stuff.
Awesome. And I suspect if you're doing that, then you're working with data that could be relatively new or relatively old and a whole variety of systems.
Right. Yeah. It's all sorts of different types of data from all sorts of different types of systems over long periods of time and through different folks that manage it.
Cool. And we're going to talk about the data ingest service. You have many services as you've migrated to cloud that are now running in AWS, correct?
Right, yeah. So this is just the ETL ingress tool.
And I suspect that's pretty challenging given the types of data that you just mentioned.
Yeah, so our goal was to create something that was flexible and would allow people to experiment with writing transformations and validations and giving them quick feedback while they do that.
Right. Awesome. So let's talk about the process. So you've got a person here. They're going to send data into this ETL process?
Yeah, so they're using a web UI, and that UI is a kind of interactive experience where they'll initiate an upload or connect data from an external source, which will flow into our ETL tool.
Okay.
In Mesos and Marathon.
And so you said flow, so that's a stream? You're streaming data in?
Yeah, so they'll be streaming the data in from, if you have a big, huge CSV, you can make an upload request and you'll start seeing the structure of the file that you're uploading, as well as any issues with it within a second or so of
Awesome.
Initiating that request.
And then they can start to manage the transformations while it's streaming.
Yeah, so they can start to fiddle with their data and play with different transformations and validations while it's still uploading.
That's super cool.
Yeah.
So I see we've got Docker and Elixir here and Mesos and Marathon. Why don't you tell us a little bit about what's going on here?
Yeah, so we recently moved from a physical data center to AWS, and Mesos and Marathon were a piece of that. So yeah, pretty much all of our newer apps are deployed on Mesos and Marathon using Docker containers that live in ECR.
Awesome.
Yeah.
And then tell us about Elixir. What's the role of Elixir in this application?
Yeah, so to generate kind of interactive and quick feedback in the user experience, we are using a lot of WebSockets and pushing a lot of insights about the data as they come in. And Elixir has really great support for that. And then the other kind of reason we're doing that is we have a smallish team working on this ETL tool, and we have other responsibilities. And Elixir provides really nice fault tolerance, so we don't necessarily have to separate our API layer from our transformation layer.
Right.
We just deploy it as one app. And that cuts down a lot on the overhead of having a billion microservices to deal with.
Sure. So it's the operational overhead, as well as giving you lots of performance so that end user can get their queries back really quickly.
Yeah, yeah. The real-time aspect is nice.
So what happens? So we've got some data, maybe a CSV file that's flowing into the cluster. What happens to that data?
Yeah. So your upload request is just going to go to a single node,
Okay.
at which point it's going to slice your data vertically and store the actual data in S3, as
Okay.
well as some metadata about that in RDS.
Okay.
So that's pointers to chunks of data in S3.
So you're going to take that data, you're going to slice it into columns,
Yeah.
and then you're going to take those columns and slice them
Horizontally.
horizontally into chunks. You're going to store those chunks in S3, and then you've got pointers to where those chunks live in RDS.
Yeah. And then as the data set is getting put in S3, the user can start to write transformation rules, which will then, as they run, read data back out of S3, and that will happen across the entire cluster. So
Awesome. So it comes into a single node, but then as your users working with it, it's spread across the cluster.
Yeah, so they're writing their transformations in this simple programming language that we built called Socl, which is Socrata query language.
Okay.
And that expression that they build executes in parallel across the
So
cluster.
tell me about the size of a typical data set.
We're not really talking about like big data like people
Yeah.
like to throw around. It's not like petabytes, but they're substantial sizes, and so several tens of gigabytes or several million rows.
Right.
That's some of our larger ones. We also deal with a lot of really small data sets,
Sure.
and the nice thing about having kind of a lightweight tool is that it also scales down. So
Right.
so people, it's not a big heavyweight thing where you're submitting jobs to a job server and they run against a 100-row data set. It's it works well for small and medium to large data sets.
Awesome. Well, this is a really interesting architecture. What would you like to do with the architecture moving forward?
Yeah, so I think moving forward, as kind of one of the aspects of moving from a physical data center to AWS is before we had no ability to kind of scale up or scale down
Right.
on demand. So we haven't gotten there yet, but that's one of the things that we're looking at. And the nice thing about this setup is when we kind of do want to manually scale things, all operations that the user is doing just get faster.
Right.
So that's a pretty nice aspect. But yeah, eventually we're
So looking at doing maybe some auto scaling in the future.
Yeah.
Awesome. Well, thank you for telling us about your architecture. This is really cool.
Yeah, thanks for having me.
Thanks. And thank you for watching. This is my architecture.